Prapti Sangvi, and this is my Agentic AI for the coursework, that is special topics in artificial intelligence engineering and application. Today I am going to walk through the production ready Flash Flood Evacuation System that I've built using n8n, Google Gemini AI agents, and multiple real world data sources. The main so in here, as you are able to see, first let me explain why the flood map, because Houston, Texas experiences severe flooding regularly due to its low elevation and proximity to the Gulf of Mexico and inadequate drainage infrastructure. When the hurricanes or heavy rainfall occur, emergency managers need to make critical decisions very quickly: which areas to evacuate, which roads are safe, and how much time they have before the water levels become dangerous. So, when the traditional monitoring systems they simply return the water current levels, but the emergency managers need answers to very specific questions: which gauge will reach the flood stage, and if so, when? Which roads will become impassable first? What the evacuation window is, and how many hours do we have, and which routes are safe for the evacuation. So rather than just showing raw data, my system uses three specialized AI agents to analyze the conditions and provide actionable intelligence. It monitors multiple gauges along the Buffalo Bayou and Brace Bayou, that is the Houston's two most flood-prone waterways, and provides forecasts with specific timelines. So let me walk you through the system. The system autonomously, it just independently runs triggers every 15 minutes, but it is inactive at the moment. So we are using the scheduled trigger for the every 15 minutes over here. There is no human intervention that is required, and it continuously monitors conditions around the clock. And I'm integrating four independent data sources to ensure its reliability. To start, the first one is the USGS real-time gauges. This is the US Geological Survey's water data service, and I'm pulling current water levels. This is the website. So as you are able to see, the value changes over here. So basically, we are measuring the timestamps for the two critical gauges, that is station Buffalo Bayou and at Houston, and station on Brace Bayou. Then secondly, we have the NOAA tide gauges. This is the National Oceanic and Atmospheric Administration, which provides backup water level for the Galveston Bay. For that, we have opted for. And the third we are implementing is NWS weather forecast. This gives us the current weather condition and forecast, which helps us explain why water levels are rising, and is it ongoing rainfall or just a runoff. So this is the NWS weather forecast. And then we have the NWS flood alerts. This is the weather service which gives us the official flood warnings, watches, and the advisories, and I'm passing these to add context to the gauge readings. Then comes my data validator, the custom data validator. Before any data reaches the agents, we will go through this validation for the comprehensive validation, and because it essentially checks the data completeness, reasonableness, freshness, and cross source consistency. So if USGS data is bad or missing, it will trigger failover to the NOAA. and once it is validated, the data goes through the transformation nodes that standardize formats, calculate rise rates, maps the road elevations, and prepares everything for the agent analysis. So in here, as we are able to see, we get the data from all the sources, that is USGS, NOAA, and WS alert data. So we are setting it as null. Then we are getting the data from the connected inputs. Whether on then we are trying to go through the fallbacks also, if there is any. Then we are parsing the USGS gauge data. Once that is done, we are parsing the NOAA tide data, then the NWS flood alerts and the NWS weather forecast. Once that is done, we are validating the there is validation and the quality assessment that is done. Once that is done, we are going for the validation report, and the validation data quality warnings has been set. Once that the cross validation and the risk assessment is done, we go for the determination of the overall data quality, and then we select the primary data source. We calculate its confidence level, whether there are warnings or heavy rain forecast and everything, and then we return the complete validation results, and this is the output of the complete validation results. So once that is done, then there is the agents, the AI agents processing. So this is the controller agent. Controller agent receives the validated data and performs threat assessment. So it classifies the situation as critical, high, moderate, or low based on the specific decision rules. So we have the decision rules. There is the data quality, validator, purpose, workflow. We are transforming, then there is critical threat, high threat, moderate threat, low threat. We are generating the response, and critical reminders are you must call the tools, do not make up the data, always validate before transforming. Base decisions on actual data readings, not assumptions, include specific numbers, that is water levels, rise rates in your reasoning. If data quality is poor, say so and reduce the confidence, and consider NWS context if available in transformed data. Once this is done, then we go for the flood predictor agent, and this performs hydrological forecasting. It basically takes current water levels and rise rates and projects future conditions at 6, 12, and 24 hours, and it will calculate exactly when each gorge will reach the flood stage, when roads at specific elevations will become impassable, and provides evacuation time window. So input, you receive gorge readings with the current water levels, flood stages, and rise rates. The role would be forecast weather levels for next 6, 12, and 24 hours. Calculate the time until each gorge reaches the critical thresholds. Then the forecasting rules we have mentioned. Once that is done, this would analyze the gorge data and how the output should be. Then we have the road safety agent. This will analyze the infrastructure. It knows the elevation of every major road near the monitored gorges and will determine which roads are currently flooded, which will flood soon, and which will remain safe for evacuation. So this prioritizes the road closures and identifies the safe evacuation routes. So here we are giving the role to determine which roads are currently flooded, calculate which road will become impassable, identify the safe evacuation, and the analysis rules are also given. A road is flooded if the nearby gauge level is greater than the road elevation minimum feet. Then we are going also to calculate time to the flooding, and if time is negative or 0, that means the road is already flooded. Then we are analyzing the data and the output, how we want the output, that is provided. And then finally we have for the same is the emergency report aggregator. So finally, the emergency report aggregator will combine all the three agent outputs into comprehensive report. So this gets sent as an HTML format, email alert to the emergency managers, and it gets logged to the Google Sheets for the historical tracking. That's the architecture. The main multi-source data collection, custom validation, three agent processing, and actionable output. So now let's see it up and running through the USGS real-time gauge. The data collection is happening. It takes about it takes some time depending on the API response times. So the log system health, each of the system health log. So I will show you the system health log for the same sheets. This is currently the system health log that we have logged. So if NOAA data is available, it will show available. If not, it won't. So now all the four of them have been executed. Getting the flood prediction data, and then we will see the road safety agents output. Workflow has executed successfully, and we are appending the predictions also in the prediction log. So we have appended as of now in the system health log and the prediction log. In the emergency report aggregator, we gather the outputs of all the agents and then we are just combining. So this will give the gauge analysis, the kind of summary, the road analysis. So we have the currently the road ID wherein it is I-10 West. It is given for the motorway, road O2, that is highway 288 for the trunk, and the Memorial Drive as a primary one. Recommended actions is provided, so all analyzed roads are currently safe. Continue monitoring the gauge levels. Safe evacuation routes, they have mentioned all three of them because there is no current threat as of now. The overall assessment is given. Currently, no gauges are forecasted to reach the flood stage within next 24 hours. And the controller reasoning is undefined as of now. So this is how we do it. If in the worst case condition, if we are not able to collect data from the USGS because that is our primary source that we are considering, then the email would be sent that we are not able to collect the data. This is the critical system alert and the flood monitoring system cannot obtain the reliable data. So the email would be sent out. And here also we are going for the if it's a false, then send validate a data validation error alert. So again here data validation failed and this would go as a result for the same. And also in here we are adding that, so if this collapses or if it does not run successfully, then also we are sending the email that there is a, if there is a threat, then in that moment of time we are sending this alert that there is a flood alert. Now this has happened. We have another NAT system that we have done to get the recent health logs and for the managers to get that reports. So this would run every hour, and once it is run, it will fetch the data from the existing files. It will analyze the system health and classify the alert and determine the escalation. And if it passes, then there will be duplication, and then there will be a bifurcation that whether the alert should be sent or not. If it should be sent, it would be sent to the important contacts, emergency escalation contacts. It would be routed to the proper appropriate contacts. Then there would be a logging that would again happen, and that log escalation would again go to the Google Sheets and it would get logged. Then in the contacts it would be split. Email notifications would be sent out. This is the formal delivery log, and again once after it is sent, it would be logged that it is sent. So all of that data is also alert acknowledged, and this is the escalation rules that we have set. Then there is this escalation contact, so these are the contacts that it will first filter out and everything. So this is my Agentic AI system, very real time, real world application that I've worked upon. Thank you so much.